Welcome. In this video, I'm going to go over an application of calculus. Namely, we're going to talk about applications of exponential functions using technology and using the chain rule. So fishermen are able to estimate the age of these fish I'm not going to try to pronounce by counting growth rings in the fish's ear bones. These long-lived fish have lifespans averaging 120 years. The data table below show the length of these rockfish at age t years. So here's the age in years and the length of the fish. And let's use the data table to estimate dl/dt when t equals 15. This is something we've done already by using the slopes of adjacent secant lines and finding the mean. In practice, we're going to look at points including 1527 and find the slopes of two sets of secant lines. So first we're going to use 1426 and 1527, then 1527 and 1632. We'll find the slopes of the lines connecting those points, and then we'll find the mean of the two slopes. To spell this out, what we're doing is computing. So we're going to compute the slope of adjacent secant lines. Let's start with the line connecting 1426 and 1527. Let's call this slope m1, and this is equal to 27 minus 26. And before I continue, I just want to remind you guys that this is our standard formula we've been using, y2 minus y1 over x2 minus x1, to compute the slope all semester. So in the denominator now, we're going to have 15 minus 14. Now this just equals 1 over 1, which is 1. Next, let's compute the slope of the line connecting 1527 and 1632. We'll call this slope m2, and this is equal to 32 minus 27 divided by 16 minus 15, and this just comes out to 5 over 1, which is 5. Now let's go ahead and add those two slopes together, and that'll give us dl over dt once we divide it by 2. So dl over dt can be estimated by adding together m1 plus m2, then dividing by 2. This equals 1 plus 5 over 2, which is 6 over 2, which is just 3. Next, part B, let's use technology to find an exponential model representing the length L of rockfish at the ages t. Please go to geogebra.org/classic, which I have here. And then you're going to go to View, and you're going to select right there, spreadsheet, and uncheck algebra and graphics. If I went too fast, please rewind the video and try this again. And I went ahead and adjusted my screen just because I want to see some of the data and the spreadsheet. So I'm just going to type in the numbers 1 through 20 because our data is for fish aged 1 through 20. Now I'm going to enter their lengths in inches. So let's start with 8 and 7.75. 10, 12, so on. Now, if you're in my class, you need to do this because you're going to need to save this file and use it for your quiz that's coming up. So please make sure you actually save the file at the end when I show you how to save this file because you'll need it for your quiz. Now that that is all entered, you're going to want to select all the data. So go to the cell A1, so the top left, select it, then hold your shift key and down arrow to select the column. You can then select the right column by hitting the right arrow and just continue clicking downward until you have all 20 rows selected. Next, you're going to go to this icon here that looks like a chart, a bar chart, and you're going to click on it and go to 2 variable regression analysis, which is not something we discuss in depth at all in this class, but it doesn't mean you can't know how to at least use this tool. So you're going to select that, and look, we get all these dots here. We get a scatter plot, which you have seen in my class before. Bear with me while I resize this a bit. There we are, and there's my data, and you can see there it is plotted. So if I scroll up and down, I can still see the age in years and then the inches on column B. Now, bottom left of the chart there, it says regression model, and it's none. You're going to scroll down till you see exponential and click on it, and it makes this line of best fit. We're not going to go over the math behind all that, but we do want to change a setting. Let's see what the rounding is. So I'm going to go here to settings real fast. It says 2. Let me change it to 3 because it's giving us 4 right now. which is weird because it's set to 2. Close that. Okay, now it's set to 3 decimal places, so please do that on yours as well. And as you can see, I went ahead and changed the screen again, and that way we can see that model right there. I'm pointing to it, the red arrow, and be able to see what I'm writing on the screen at the same time. So our model, L of t, is equal to 7.244. That was a bad 7. Let me redo that. 7.244 e. Now the exponent is 0.097 t. Oops, I almost did an x there. Now, if you're going to struggle remembering this, write down some notes for yourself in the space provided of how you did this, since you'll need to do this again on your upcoming quiz. So you're going to go to geogebra.org/classic, and then you're going to select a spreadsheet from the menu, the top right. There's those 3 bars. You're going to click on them and select spreadsheet. You're going to go to enter data, then choose 2 variable regression analysis, and then you're going to select an exponential model, or maybe a different model if that's required. Now let's go ahead and use our model to estimate dl dt when t is equal to 15. And so dl over dt is approximately, well, it can be approximated using our model L prime of t, so the derivative of our model. And this is an exponential function, and it has a function within a function. You see we have this linear function in as the exponent, so we're going to have to also apply the chain rule here. So the derivative works out to be 7.244, and then we have e to the 0.097t, and then we're going to multiply by the derivative of the inner function, the linear portion, and that's just going to be 0.097. And then get a calculator out and multiply this together. You are going to need to know how to do this, so hope you pause your video and get a calculator out. L prime of t is equal to, and we get 0.703 e, and then our exponent's the same, 0.097t. And we're going to use that now by plugging in that 15 and estimating dl dt when t is equal to 15 this way. So that's L prime of 15, which is 703. I'm just using the same model, the derivative of the model we came up with, and then I'm replacing that t with a 15, so 0.097 times 15. And on my calculator, that works out to be, please pause the video and get your own calculator out as well and try this. And it works out to be about 3.012, which is really close to what we got from our table. If we round to the nearest whole number, even to a decimal place, we're going to get 3 either way. So now this next part gets to the heart of what we really want to know. What are the units of dl dt? And what does dl dt represent when t equals 15? That's especially important. Well, dl over dt, let's get used to this notation. The top here is length, and the units of the length are in inches. So the units of L are in inches. And then the denominator here, t, the units are years, because t is, the age of the fish in years. Okay, so that helps answer this first part, but let's write down a complete sentence. The units of dl over dt are in inches per year. Okay, so now let's talk about the second part. What does dl dt represent when t equals 15? I'm going to start by writing dl dt again, just so you guys get more used to this notation and what it means. And our numerator here, that is telling us that this is the change in L, the change in length. And the denominator here is the change in time. Now, literally what this is, and we'll get into more of an explanation next, when t is 15, dl over dt is 3. Now let's put this together with what we know about units to really answer this question. At 15 years of age, pardon me while I move my screen. So again, at 15 years of age, these fish are expected to grow 3 inches per year. Excuse me, at a rate of 3 inches per year. Now let's talk about how to save your file. I already have an account created, so it'll be a little easier for me. You'll have to create a GeoGebra account. So you go here to the 3 bars, that's where all the menu is, and you hit save, file, excuse me. Save online. I would suggest just saving it online. If you want to save it to your computer, go right ahead, but you might have a harder time using this on the quiz. So save online, and go ahead and save it as spreadsheet for quiz or module quiz. There you go, and hit save. Those of you without a GeoGebra account will be prompted to create an account. Please just create one and use it for the quiz that's coming up. All right, well there you have it. I hope you found this video helpful. Please keep calm and math on.